Welcome back, everyone. So we were talking about our interfaces versus types. So types are a different style of coding out our objects and typing them. The way that type works is very similar to interface, except you don't need the I. So we can say interface of iSearchBoxProps can be converted to type searchBoxProps, like this, except we need to use an equal sign. And then inside, we need to define an object that represents the shape of this props object. Similarly, we'll do the same thing. Class name is string, nothing different here. Placeholder, also the same. If optional, can pass the question mark, also a string. And then for the actual function, once again, we can also put a function. And now we can just put this searchBoxProps as the type. Now you might be wondering, what is the main difference between using a type versus using an interface, other than the fact that interfaces offer us the ability to extend and offer us the ability to overload, like so. Types allow us to do something known as a union. Now a union is essentially a combination of types. So let's write one out so I can give you an example. Let's say we had some variable that was an address, and the address could be equal to two different styles of objects, maybe one for US addresses, maybe one for Canadian addresses. So the difference would be that here you would have, of course, your street, which is a string, and you would also have your state on the US, which is a string. But if you are in Canada, this instead would be a province, which is also a string. So in this particular case, we know that the state and the province are optional, but they can exist as either one. How this would work is that we could say that there is a type Canadian address, which is equal to this that needs, of course, your street, which is a string. But also, you could have a province, which is a string. And similarly, we have a type US address. And here, street is a string, but state is also a string. Actually, this should be province, like so. In order to make a union, we could say type North American address is equal to Canadian address, and then this one bar US address. We've created now a union type, meaning that address, if being passed our union, can now represent both a street with some value, or it can have a state with some value, as well as a province. Both are equally valid. You'll notice that this is perfectly fine. Province works, state also works. It's not throwing for us any additional errors. Now, nothing is stopping us from adding any additional union types on top of this. We can add something like an Italian address. And this also has a street, which is a string, but it also can have a region, which is also a string. This region, of course, could be something like Tuscany or Amalfi. But now, if you add this, once again, this still works. If we didn't have Italian address, then of course you see that we have an error because this cannot have region inside of our North American address. So of course it's no longer North American. We can probably just put Western, or we can just put address if we think it's going to extend. But this is the thing about types. You're allowed to do unions on them. There's also a couple other advantages which we'll discuss once we use more of types, but this is really a preferential choice. A lot of projects like to use interfaces. A lot of projects like to use types. Typically, the golden rule is that if you are writing more of a functional style of code, functional programming style, then you use types. If you do more of an object-oriented style, then you use interfaces. Personally, I like functional programming a lot, so I am going to continue using types for the remainder of this course, but you can feel free to use interfaces. It's pretty common in its overlap, so there's not that much difference. So what we need to keep then is pretty much just our search box props type. So here, one thing you'll notice is that our function definition, while we just type something, this is not correct. We actually are not even receiving the correct value here. The reason why this is not the same is because you'll notice that here, inside of onChange, instead of directly just passing onChange handler like so, I've written it another way, where we're explicitly getting the actual event inside of a callback, which we then pass to our onChange handler. Now, the reason I did it like this is because I want to know what this event is that we're getting from React. And this is very important because React actually has a lot of types by default inside of all of these components that they've given us. The reason why React has typed all of these HTML but Reactified JSX components is so that we can actually use Typescript with them. In this particular case, if you switch back to this version, you'll notice that onChange gives you an error. It says that our type of this function, so you see type a string, fat arrow void, is not assignable to type change event handler HTML input element. Change event handler is actually a functional type definition that we get from React. So here we can import this in from React. And it's called, if we highlight over it again, change event handler. Now, change event handler is essentially a function type that we receive from React. We can put this here. And what we also need to pass it, if you remember, when we had our definition like this, where we received some kind of event. Notice that this event is of React change event HTML input element. Here, we want to pass that HTML input element into this change event handler. Because if you hover over this, reading this definition, alias, type, change event handler, notice that there are angular brackets. This angular bracket is essentially representing that you can pass to this type a parameter. The same way that you pass a parameter to a function, certain types by definition, you can actually also pass it a parameter. This parameter, though, is a type. You have to pass it a type so that it can use that type inside of its own type definition. For example, what you're seeing here with change event handler is that it receives some parameter value of t. This t has to be some kind of element type. Now, element here is a union. It's a numerous bunch of different HTML element types, of which HTML input element is one of them. So what happens is you pass it this parameter t, and then it uses it to define what the change event type is going to be. So notice that we say equals and then round brackets event, change event of type t. So we're saying, hey, give me some type t, and this is going to be what I use to define the type that I have later on. If that seems confusing, don't worry. We're going to work with these types of type parameters. These are known as generics, and we're definitely going to explore those. For now, though, all you need to know is that we are going to pass to it a type parameter of HTML input element. And now this change event handler is correct. So we don't even need this anymore. And here we go. We see that everything here works. The reason why you can pass this different input elements types is because there are actually onChange methods across many different HTML components. Input is just one of them. We have it for text boxes, we have it for dropdowns, we have it for radios. There are numerous different components that register an onChange. As a result, depending on which input element is triggering this onChange, they might have different values on the event. So React is saying, hey, tell me what type of onChange this is going to be. So I know that this function is ready to receive the correct event type. Again, React is typed by default. The fact that it's typed means that all of these components have these type definitions and what they expect on their methods themselves. So as a result now, this extends for us a way to leverage these existing types that React has made in order to define the functions that we'll pass to it. Many libraries by default now have TypeScript in them because, again, TypeScript is so popular. And by doing this, we need to always import some of these types so that we can make sure to the library that we're giving it what it wants. So this is probably the part where it gets a little challenging to learn TypeScript because you do need to constantly reference the documentation in each of these libraries to know what the types you receive will be. But over time, you'll pick up some of the patterns, such as what I just showed you, where you can just look at the actual things that are being passed to you. This is one of the beautiful things about using VS Code for TypeScript, because VS Code and TypeScript are both made by Microsoft. So by default, TypeScript is embedded as the engine that runs VS Code. So the compiler is extremely accurate and helpful. But this is it. We have typed out the search box component. We've learned quite a few things actually about types, interfaces, strings, and functions, as well as third-party library types that we can inherit. And we started to learn about these type parameters that we pass known as generics. So I know this is very, very overwhelming, but I guarantee you once you learn more about TypeScript, you'll actually learn way more about JavaScript and you'll get really intentional understanding how JavaScript works. So now that we have finished typing our search box, let's continue typing the rest of our project. I'll see you in the next video.